Hi everyone, this is lesson 5.5, Solving Rational Inequalities. Just like other functions, rational equations may not necessarily always equal to each other. Sometimes they might be less than, or bigger than, or less or equal to, or bigger or equal to. So when it comes to solving inequality, the solution should be all possible values that satisfy the inequality. And in most of the cases, there will be more than one solution. Rational inequality is an expression where one rational inequality expression is less than, greater or equal to, less than or equal to another expression. Only at certain times where each denominator is positive, one can multiply both sides by the lowest common denominator that we have already talked about in previous lectures. Taking a look at example 1 from your learning resources. Determine the value of t where 240 over t plus 8 is bigger than 20t divided by t plus 1. In step 1, we can see that denominators are all positive, so we can multiply both terms by the lowest common denominator, which in this case will be t plus 8 in bracket times in bracket t plus 1. And so we do so in this step, the second line here. We do all the algebra and we will end up with 0 is bigger than 20 times t minus 6 in bracket times t plus 2 in bracket. So in other words, in bracket t minus 6 in bracket close times t plus 2 has to be a negative value. In step 2, we have to find the interval where it can be a negative value. So let's look at the interval where t is less than negative 2. We plug any value that t is less than negative 2 back into this equation of 20 times in bracket t minus 6, and we get a negative value. We plug any value that t is less than negative 2 into this equation of t plus 2, and we also get a negative value. Two negative make a positive. So this is not good because we want a negative value, not a positive value. When we look at the interval from negative 2 to 6 of t, when we plug a number from that range into the original equation of 20 times in bracket t minus 6, we get a negative value. And when we plug a number from this range back into t plus 2, we'll get a positive value. A negative times a positive will equal to a negative. So this range is good because we got a negative value in the end. When we use a value that's bigger than 6 and plug it back into this equation, we get a positive value. And when we plug t is bigger than 6 into this equation, we also get a positive value. Positive times positive equals to positive, so this is not good because we want a negative value. Therefore, this inequality expression is only true when t is less than 6 but bigger than negative 2. Now let's take a look at example 2 from your learning resources. It asks us to determine the value where t plus 3 divided by t plus 1 is bigger or equal to t minus 2 divided by t minus 3. Well, in step 1, we have to make a restriction in which t cannot be equal to negative 1 or 3 since they're not in the domain. And if they are, we will get a 0 in the denominator. So then this original equation can be made into this equation shown on the slide, and now we can multiply both sides with the lowest common denominator. At the end, we will get t minus 7 is bigger or equal to 0, therefore t is bigger or equal to 7. So 7 is included in the solution set because there is an equal sign here. Next, we have to find the intervals because there's obviously more than one answer. When t is less than negative 1, we get a negative value when we plug that value into t minus 7. At t minus 3, we get a negative value, and when t plus 7, we get a negative value too. 3 negative make a negative. A negative sign is not what we want because if we go back to the previous slide, we have this sign here. So we want something that's bigger or equal to 0. So we want something that's positive or 0. So let's go back to the slide and look at the interval where t is less than 3 but bigger than -1. When we plug that into the first equation, we get a negative value. When we plug that into the second equation, we get a negative value. And for the third equation, we get a positive value. A negative divided by a negative times positive equals to a positive. So this range is fine. For the third range of t is less than 7 but bigger than 3, when we plug into the first equation, we get a negative value. Second one, we get a positive value. Third one, we get a negative value. Negative divided by 2 positives equals a negative. So this is not good because we want a positive value. When t is bigger than 7, we get a positive for the first equation, a positive for the second equation, and a positive for the third equation. So we get a positive overall. And we have already established that t is bigger or equal to 7, so obviously this one is good. However, we had the restriction that t cannot be equal to -1 and cannot be equal to 3. Therefore, our solution set is x belongs to real numbers such that t is less than 3, bigger than -1, or t is bigger or equal to 7. When we have to graph that into a number line, you can see that there are two discrete intervals in which one is x is bigger or equal to 7. So we fill this dot in. This is not a hollow dot because 7 is included in the solution set. But for the set that's -1 to 3, we draw two hollow circles because -1 and 3 are not included in the solution set. It is actually undefined at that point. But everything else that's in between is defined. So that's the end of this lecture, and thank you for watching.